So, welcome everybody. Thanks for showing up. There's probably going to be some people still joining us after lunch. We'll be kicking off this afternoon with the Immersion Project update. So there's a lot of activity going on. John Bean and I are jointly leading the Immersion sub-project to the cooling environments. It's one of the most active projects in OCP at the moment. We've got a tremendous amount of work streams, work efforts going on. We're dealing with a very active community. Most of you are part of it, so most of you are familiar with it. We do have a monthly call in which we deal with all the workstream progress, where we give some attention to some special interest topics, right? So we try and bring in some new ideas, new insights every month. It's becoming more difficult with the additional work streams that we've got recently. So make sure to dial into this monthly calls if we want to keep up to speed, keep updated with where things are heading with the Immersion community. And I'd love to get all your participation. So if you are not already signed up to these Immersion calls or to any of the work streams, please do so. The calls are open. At the end of the deck, there's going to be an overview of all the sessions that you can dial into.
Yep. Yeah, so we do have quite a few active work streams going on right now, probably as many as we've ever had within this project group, I think. So we have the Immersion Requirements document, which is an ongoing document that Rolf and Michael are working on now as the leads for that work stream. We have the materials compatibility. Interesting, it's advanced along, and we've had a change of co-leads on that. I was the co-lead of that, but we got it into the IC. We'll speak a little bit more about that later. And we've got Kai from UL that's taken on a co-lead role with that work stream as well. We have power distribution and immersion. We'll hear more about that. That's focused more on the ORV Type 3 architecture there, getting that into racks with immersion technology. We have Oriole, and I think Harry is going to be speaking to this a little bit later. And then we certainly have hardware management for liquid cooling, and you all got to hear a really good presentation from Mick Jones earlier, speaking about the schemes that are being pulled together and touching on a whole bunch of diversity of platforms there. Immersion Cooling Hurdles is another work stream. We've got two leads on there. We've got David and Raul working together as co-leads there to advance that. We'll be hearing some more about that as well. And then certainly Rolf and Chang are involved in the OAI collaboration as well.
Yeah, and in addition to that, we are already looking at a couple of more work streams within the Immersion umbrella. First of all, one of the main hurdles that has come out of the hurdles work stream, David will be speaking to that in a couple minutes, is the warranty guidelines. IT equipment that gets immersed into a fluid currently usually loses warranty, right? These are things that are often mitigated with the manufacturers chipping in on a project basis, but we are looking to harmonize the methods of, hey, how do you deal with warranty issues with the server manufacturers and chip manufacturers? A second work stream that we're going to be scoping out in the next couple of months is the TCO modeling for immersion deployments. Right? There's a lot of benefits regarding cost, but it's very, very often difficult to assess, hey, how are you going to be earning back the investment in an immersion technology? It's very often that immersion tanks are being compared to racks, which is an unfair comparison, right? So where do these costs actually come back? How do you earn that back? Where do these benefits really sit in your TCO model? That's what that work stream we'll be looking at.
And then another work stream, we have the CDU spec for liquid cooling. And of course, you all are aware, listening to a number of people speak, that the liquid cooling for CDUs is a little bit multifaceted. It has maybe immersion support, maybe it has rear door heat exchangers, maybe it has direct to chip. So it is going to be a cross-community kind of activity there. I think hopefully we'll start out with something like a base specification and kind of get the foundation, put together for that to build on top of that. But that is going to be a very important specification, so people will understand as these things get put in their data center what to expect and how they may impact their data center.
Absolutely. And this is a work stream that is actually has come up as part of the ACF discussion, the Advanced Cooling Facilities Group, which is looking at trying to define the CDUs, and we'll be looking at this as the Immersion project as well to facilitate that work effort.
Yeah, so we do have a fair amount of completed work products. We do have a lot in process, but we actually have a lot that we've actually either put into the IC or has been approved by the IC and published. So right now, our warm liquid cooled facilities is being submitted to the IAC and will be in their hands quickly, if not already. The materials compatibility, hey, congratulations to that whole team for immersion cooling. We finally got that submitted to IC, so it is truly in their hands. We anticipate getting that approved in the very near term, and we're looking forward to publishing that. I know a lot of people have been very curious about that, and we're very anxious to get that out to the community. Obviously, it'll be built on, and Puneeth will speak more about that later. We also have design guidelines for immersion cooling that's been out for some time, since 2020. Again, the immersion requirements, we're on Rev 2 now. We published Rev 1 back in 2019, and then in 2022, I guess it was, we published the second one, early 2022, I think, pretty darn early, yeah. And then open cassette specification, that's a specification for a chassis, basically, for immersion cooling. And then the fan simulation specification. I think many people know early on that a lot of firmware didn't understand if the fan was removed, and there was a simulator there that allowed the thing to say, okay, there is a fan there even though there wasn't. So a lot of things have been already completed and out there, and we're looking forward to building quite rapidly on this list.
And then we got some work products that are nearing the completion, and one of those is the Rev 2 amendment from the Immersion Requirements. I'll get into that on the next slide. And last but not least is the Intel fluid specification. I think you must have heard about it from some of the Intel sessions. I think Intel's made a point of it to mention it in every one of them, which is fantastic. It's a very fundamental piece of work that we currently have under review. We expect to complete the review process by the end of this month, or early next month, hopefully. And after that, we'll be passing on to the IC, and by that time, we'll be able to communicate a lot more about this.
Yeah, and it's quite obvious Intel put a lot of thought into this before they brought it into OCP, so it really is in a pretty good advanced state of completion, but they're getting the buy-in from OCP to help advance this, so very much needed and appreciated.
Exactly. So a little bit about the Immersion Requirements workstream. I'm going to keep this fairly short because it's in progress. The revision 2 is in place. I think actually it was early last year even, early 21 even, that it was published already. So we've been looking at expanding and correcting some of the materials, pinpointing some of the figures. I'm currently happy to say that we've got a fantastic co-lead now, which is Michael Sakamoto from UL. And the whole background behind this is to generate a baseline of qualifiable requirements and required disclosures for immersion cooling technologies, right? We don't want to see any prototyping products getting onto the market. We want to see this industry get to a high maturity level. So it contains a mix of explicit requirements and some white paper content in terms of best practices. This is how you can look at these things. These are proven ways of achieving certain goals. And vendors in the OCP domain are required to qualify against these requirements. And it's all about stimulating a certain level of quality within the immersion domain. What we're currently looking at, what we're currently dealing with is a couple of suggestions that we've added to the requirements. First of all, it's a BIM file publication requirement. So it's already been accepted by the group. We're going to require every vendor to also upload and submit a BIM file, which is a very high-level design format which indicates the basic geometry of a solution and all the important interface points. Where's the power connector? Where does the water plug into? And what is the exact position, which helps with the facility planning ahead of deployments. This is something that has also been driven by ACF. We're waiting for a final specification for the bin file format so that we can attach it to the same requirement so that people can actually start uploading and generating these bin files. The second topic is the auto-ignition temperature of the immersion fluids. Currently in the Immersion Requirements Rev 2, we've stated an auto-ignition temperature of 250 degrees C. However, there is an existing official standard within IEC, that is the 62368, which has been broadly discussed here in the cooling environments as well. UL will speak to that later on as well. And that standard actually states a temperature of 300 degrees Celsius. So we're going to be harmonizing with that figure for now. There are some discussions around, hey, whether that's appropriate or not, what is it based on? And as a secondary workload, we're going to be looking at ways of finding some data to back up, some independent scientific data to back up whether a specific temperature would be more suitable for this particular application. A lot of this information comes out of the transformer industry, high voltage, and closed systems, whereas what we're talking about with immersion is very often open bath, very low voltage. So we're not talking about 40,000 volts in these tanks, we're talking about 12, 50 volts, 230 volt systems that are being immersed. And finally, one of the very interesting topics is the thermal loss to air definition. If you've got an immersion tank, right, inside the immersion, 100% of the electrical energy is converted into heat, it's captured by the fluid. And the fluid is being cooled down with a water circuit, usually. But hey, the tank radiates heat. So there is some thermal loss to the air environment. So what we're looking at now is, okay, how do we quantify that thermal loss to the air environment? And how do we come up with methods that every tank provider, tank manufacturer can include in their process to verify how much thermal load is being lost to the air environment? That is necessary to help, again, with the facility planning, because, hey, it's great that you've got a liquid cooling setup, but it still warms up the air, so you do need some air treatment, and it needs to become quantifiable.
Yeah, it needs to be basically a specification for the product.
Exactly.
People know exactly what it is, absolutely.
And John, maybe you want to speak to the last one regarding the Intel fluid spec, because there's going to be some material on the material compatibility workstream. Yep. There's a lot of items coming out of that spec which will become relevant also in immersion requirements. But that also combined with the material compatibility.
Yeah, so we have had a couple of community calls with Intel as they've discussed their fluid specification, and you can imagine that's got a lot of interest in the community, giving input and asking questions and helping to advance that. But I think this is going to move fairly quickly and get it out there reasonably quick as you can get any specification out. But as I mentioned before, with the materials compatibility, we did make a major milestone. We did get the materials compatibility paper into the IC, and we should be seeing it able to be published any day now, so that's the good news. And I do want to again mention that we did have a change of leadership. When I took on the co-lead position back over a year ago, my ambition was just to get through the first release, and it took a little bit longer. So I remained a co-lead at least till we got that release done. But now we have Kai from UL as well that will be working with Puneeth. You'll be hearing from Puneeth a little bit later, so I don't want to really steal his thunder. But he'll be covering extensively what we have right now, where it's going. So again, since he hasn't spoken yet, I'm going to let him cover these in more detail. But major milestone that it's all but ready to publish. And here, so certainly we've had really good participation by a fairly small group of people, and this is somewhat deliberate. We had typically, most months we were having 2 calls. We had a very small internal group of folks that were actually doing the work, and then we'd report out to the bigger community to keep them apprised of what we're up to. But to be effective, sometimes these communities, they need to work with a fairly small group of people to be able to move and advance the effort. Otherwise, you'll just stay in these continuous while loops with the community at large, and you'll just never get the thing published. So that was the way we moved forward with this. But we definitely need to build on this, and we got a great platform to advance and add to, depth and breadth, and looking forward to building this into a very beneficial document.
All right, so the next one, we're going to call up Harry for this one as well. So the power distribution in Immersion workstream is a workstream that has recently kicked off. It had some startup issues. We've revived it and gave it some more energy to go forward. We've strengthened the leadership. It's currently being led by Oriol Chavanel from Subnar, who's doing a fantastic job on that leadership, and he's joined by Harry Soin, from AEI. Sorry, struggling over the letters now.
It's changing.
I know. It's so many times, right?
Yeah, exactly. So the work group is going to be looking at the OpenRec implementation and see how that's best suited and adopted for immersion. We've got a couple of slides for Harry to go through. Take it away, Harry.
All right. Thank you, Rolf. So I'll just go back to the previous slide that we had. So first and foremost, my name is Harry Soin from Advanced Energy. I'm a Senior Technical Marketing Director responsible for the hyperscale space. I'll be speaking on behalf of my partner as well, Oriol. He is my co-lead from Submer. He's the co-lead in this power distribution section. So here's the point, like, with the increased higher workloads, we have more and more thermal challenges to meet. And for thermal challenges drives higher power, as we know. So with that increased higher power, we have gone to, that has really translated this transition from 12 volts to 48 volts. All right, so that solved a few problems. We have lower currents. We are able to get better power densities. We are able to get better efficiencies. Like, we are getting close to 98% efficiency in the power converter. So, but increased power loads needs that we need to have more attention to thermal management. So, enhance this power distribution work stream. So just a little bit as to what the scope is, I'm just going to touch up on that. So, so what are we going to do? On a very high level, as you see here on the screen, the current scope here is, we will be doing the analysis of the power of this whole delivery system. So we will look at the current ORV3 system as it is and use that as a building block to see how we can adapt that for immersion. And then we will be looking at the strategies that will be needed. You just can't take a power shelf and put that in, and immerse that, right? There's connection challenges and bringing the power out and so on and so forth. And then we will be looking at the technical material that people can use to help facilitate that. So we will be looking at that. And having said that, then we need to align the specifications that we come up with ORV3 spec, right? So that becomes, I don't know, a subset, or at least we want to have a complete path. You can take an air-cooled system and have an immersion system, and we need to have a set of path how we get there. So that's a big picture. And now details. Now, how do we plan to get there? How do we plan to implement it? So, so we will start with evaluating the power shelf architecture, ORV3 architecture that is. And then we are also looking at, there is a lot of options out there right now which people are using for immersion. So we will be evaluating those and see what makes sense, what doesn't make sense. We're doing the technical analysis of all these approaches. We are looking at, I'll be getting more into detail in the next couple of slides, the mechanical aspects, the safety aspects, and really glad to have a lot of UL experts on board to help convert those into requirements as we move on. So, and then we will be writing technical specifications around those, right? And when we talk about creating schematics and diagrams, so essentially we'll have a design spec, the whole implementation aspect of it. And the last but not the least, we have the industry leads, we have the shelf vendors, we have the other customers, so we get everybody's input, and so we harmonize all that and how we move forward with that. So at the end of the day, we need to come up with what is our deliverable. So, we start with a system which is like a single-phase immersion system, but we are not limiting to single-phase. It could be two-phase. Again, that's one of our deliverables. And then we will, Rolf and John spoke earlier on that one. We will have a tank specifications, how the whole power system works with that. And then we are talking about liquid liquid and fluid specs, that's an integral part of that, right, for thermal dissipation and all the other reasons. And then the power providers will sort of harmonize or use the word standard, not standard, requirements, come up with those requirements so they can all design with that harmonious system, so we have a clear set of deliverables and a clear set of system. And last but not the least, bus bar is a critical challenge, and right now, speaking to Rolf this morning, the bus bars currently, if you take a tank, you dunk it in fluid, the bus bar is at the bottom, so accessibility is an issue. So we have to work with that from a safety aspect, from a connectivity aspect. So, that is another one of the challenges we face, and we need to face that at the end. And just moving on, my last slide. We started this in September. We have had a great participation. We have, all across the fields, we have participants from Silicon. We have participants from our customers, and majority of them from the major hyperscalers and safety aspects. So what we have looked at so far is the challenges we face with the air implementation and versus when we put that in immersion. So, what happens with the overall performance? And then we're looking at material compatibility, especially from a power supply perspective, electrolytic capacitors, deterioration, connectors, so on and so forth. So all those things need to be addressed. And then the very important aspect is we also looked at the power density expectations. If a power shelf is 30 kilowatt, can we get 60 kilowatt or more? So that's the aspect. We are looking at that right now as we speak. And in fact, we talked about during our last session. And lastly, we looked at the safety aspect, dropping a screwdriver in there or whatever. Creepage and clearance, so far the UL treats them the same, whether it's air or whether it's liquid, so we need to come up with a standard or harmonization around that. So those are the things we've been looking at, and look forward to addressing this and more during the next upcoming meetings.
All right, thank you very much, Harry.
Okay.
We're running out of time a bit, so let's address the next one. This morning we've seen the hardware manager.
Yeah, we kind of touched on this. Mick went over this, so I think he did a great job. You can get a copy of his presentation, take a look at it, but I think being that he just so recently spoke on this, we'll move on and try and keep our schedule here.
We're getting David Gyunazayan on stage now just to speak a little bit to the Immersion Cooling Hurdles. I'm going to have to ask you to keep it short because we're running out of time. And we're pretty strict on the time, as you have experienced this morning. So take it away, David.
Thank you, Rolf. So my name is David Gülnazarian, and my name is David G, in short. I'm an independent consultant focusing on data center decarbonization and heat reuse. And previous year, we had created pitch deck, how immersion cooling solve data center challenges. But this year, we are focusing on the immersion cooling hurdles. So we have found many obstacles and challenges in our work stream since March, and now we want to share the highlights. So safety is first. We need to validate standards for the hardware and fluids and facility procedures. That agnostic standards will help to immersion cooling community. Next one is servers. We don't have a real mean time between failures as there are so many components and cooling system variations. And server producers should provide servers dedicated for immersion with manuals. In addition, for previous highlights, material compatibility takes comprehensive approach, including fiber optics, high-speed network, and power supply to prevent potential issues. People mind and existing paradigm is another challenge. In air-cooled data centers, IT team and facility team are independent and have different KPIs and management. With immersion, it's easier to create project from the scratch with open-mind people. In order to deliver immersion cooling to others, we need new metrics, examples, and educational programs. Immersion cooling had much less components in comparison with air-cooled data centers, but still need operational standard for technicians and IT users, which will make maintenance easier. So we will invite all participants of immersion cooling to collaborate and provide answers for immersion cooling hurdles. Thank you.
Right, thanks, David.
Good job.
So the workstream Immersion Cooling Hurdles is a very important workstream for us in the immersion community because it helps us drive strategically towards the work focus, towards workstreams, to kick off and identify workstreams that are fundamental to the success of immersion in the industry, right? So this is the importance. We can't just hide away the things that are troublesome or things that are challenging. No, we need to attack them head on, and we need the broader community to make that happen. Finally, before I hand back over to John to wrap it all up, good to mention here, there's going to be a session on this and most of the other stuff where we didn't get a workstream lead on stage. We're working closely together with other workstreams as well, with other projects within OCP as well. One of these is part of the server project, that's the Open Accelerator Initiative infrastructure, where we are helping their team on the development of these new, ridiculously high-end chips with incredible heat loads, and making sure that they're going to be ready for immersion as well. Right, so more on that later.
Yeah, and wrapping it up, as we mentioned, we have a lot of work streams going on right now. So obviously, we have quite a few calls going on every month. We have the monthly community call that's generally well attended. We have a lot of folks on that call. It's every month, third Tuesday of each month, and it's open to the entire community. We have the Immersion Requirements call. That is by invitation only right now, and there's a reason for that because we're really working on some addendums to the existing Immersion Requirements document. So we're really trying to keep continuity of folks that were involved with that document for these pending revisions and move that through with some fairly limited, participation just to address those addendums right now. Material compatibility, it's open, and it's going to be limited to active contributors. So one of the things you find in some of these projects that really have to do a lot of work, and I kind of mentioned on this, you really need to identify the folks that are actually going to move this forward for you, and then you need to get those folks together to work on it in a collaborative manner that they can advance it. But if you keep getting people in and out of the dialogue, you can't really depend on them to actually give you the work product, and it can really derail an activity. So we're not trying to make this, because it is open, but some of these things, they just work more effectively that once you identify some folks that really want to get some work done, you let them do the work, let them report out to keep the community informed, but let them do their thing. Power distribution that was spoken to by Harry, that's open now as well. Meets first Tuesday of each month. Hardware management for liquid cooling, open as well. Immersion Cooling Hurdles, that's open, and they're welcoming folks to contribute and help move that forward. And then the OAI, this is a little bit of an interesting one. This is by invitation only as well, because this is dealing with some IP potential issues where there's got to be CLAs involved. So it's really not the kind of a work group right now or work stream that would really allow a lot of people coming in, because they would have to sign CLAs to contribute to this, else it could develop an IP issue down the road.
And that's it for today. So I think we want to close this off with the call to participation. We need your help. You see the amount of work that we're doing. You see the advancements that we're making in the community. We've got an incredibly active community, which I'm immensely proud of working with. But we need more and more help with the amount of work that we need to displace, the kind of solutions that we need to find. All of your participation is welcome. Please jump on board with these calls, especially the work streams. At some point, we're gonna be able to really state that we within OCP have turned around this industry globally, right? So with that, I'd like to leave you all and set the stage for the next presentation. Thank you.
Yep, thank you, everybody. Appreciate it.